Hello, this is my ECE 1240 Exam 2 tutorial. Please excuse my scratchy voice, I'm sick right now. But this is replacing problem 1 of my tutorial. The problem is to find the Thevenin and Norton equivalence with respect to A and B on the circuit, A and B being the positive and negative terminals. So, to start off, we need to calculate VOC, which is the voltage open circuit between A and B. To do that, I use the node voltage method. Node voltage at node V2 gives us V2 minus 12 because V1 is 12 volts. We can see because V1 node is above the 12 volt power source. So we have V2 minus 12 over 1K plus V2 over 10, the 10 ohm resistor, plus 0.2, which is that current there, equals 0 minus I. So then we have V2 times 1 over 1,000 plus 1 over 10 equals negative 2 plus 12 over 1K, which gives us that V2 is equal to negative 0.792 volts. Then we repeat that process for node V3. At node V3, the node voltage method then gives us 9.7965 volts. And so, to find our VOC, it would be V3 times 20 over 20 plus 25, which are these two resistors there. Sorry. And that would be 9.7965 times 20 over 45, which is 4.354 volts. Now the next step is to find ISC. I say find ISC, which is current short circuit, because there is a dependent source in the circuit. Now the way I found to did this was the mesh current analysis method. You can really use any other method to find ISC, but this was the one that worked well for me. Now using the mesh current method, I found that ISC was equal to I3, that current there. ISC is equal to I3, or 0.0815 amps. So then, to find RTH is voltage open circuit divided by current short circuit. So RTH, or the Thevenin equivalent resistance, I should say, is 4.354 volts divided by the 0.815 amps that we had before, which is 53.4244 ohms. So that's our Thevenin equivalent resistance. Now that we have our voltage open circuit, our current short circuit, and our Thevenin resistance, we're ready to draw our Thevenin and Norton equivalents. The Thevenin equivalent is the VOC in series with a resistor with the value of the R Thevenin, which is a 4.35 volt power source in series with a 53.4244 ohm resistor. And a Norton equivalent is a current source in parallel with the R Thevenin resistor. So that would be our Thevenin and Norton equivalents for this problem. Thank you.